Hey everyone, hope you all are doing well and welcome back to the channel. So the problem that we were discussing was from our SD sheet for the topic binary tree, and the question for today is print vertical traversal of binary tree. Basically you have to return vertical traversal of a binary tree. So before I move ahead in this question, if you have gone through yesterday's lecture, that was we were printing bottom view of a binary tree. So if you have done that, then this is going to be very easy. Okay, let me show you. Wait a second. So what was the question that we discussed yesterday? That was bottom view of binary tree, right? So if not, I'll suggest you just first go through that video, then this question is going to be a cakewalk. Let's understand what we need to do in this question. So let's have a look. You are given a binary tree. Find the vertical traversal of it starting from the leftmost level to the rightmost level. Now I'll explain it to you, although we have gone through this entirely in the previous lecture, but yes, let's see from this question's perspective. Okay, let me draw this tree and explain it to you. What do we have is, for example, we have a tree like this, which is, one second, okay, your tree is 1, 2, let me draw it properly, 1, 2, then we have 4, and then 5 will follow this, then we have 6, okay, then we have 7, 6 is followed by 8 here, 7 is followed by 9. So let me explain to you. When we traverse this tree in the vertical order, what are the nodes that we are going to get? That's what we need to return. So whenever we talk about vertical order traversal, as you know, we are talking about these verticals, okay, like this, okay. Now if you observe, what are the nodes that you are going to get on each vertical starting from left to right? So if you see on this vertical, we only have one node, that is 4. So we will simply print 4. If I talk about this vertical, this has only node 2, so I'll print 2. Talking about this vertical, on this vertical I will get how many nodes? First I will have 1. If you observe from the topmost, you have to observe it from top view. In that, if there are more than one node that are falling on the same level, then the one which comes before, that is from the left side, the node that comes before is the one that you have to print first. So looking from the top view, you will have on this vertical, you will have 1 first, and then you will have 2 nodes, that is 5 and 6. But since 5 comes first, if I compare the level, on this level, the node that comes first is 5. So I should print 5 here, and then I will have 6, okay. That's what I need to do for this vertical. Now any more nodes on this vertical level? No. Now let's talk about this vertical level. On this vertical level, I have only 2 nodes. One is 3. If I observe from the top view, first I will have 3. Although from top view, I'm not going to view 8 definitely. But try to understand what I'm trying to say is, on the vertical, all the nodes that you have from top to bottom, and if there are nodes that are colliding on the same level, then the one that is coming first from the left end is what you need to print before, okay. 3, then we have 8, and if I talk about this vertical, I have only 7 on this level, then 9. So basically this is what it should look like when you print. You have to return an array list which will have nodes in this order, and your function will take care to print it, okay. Now considering the previous question which I discussed with you, that was printing bottom view, top view, bottom view, both will follow the same logic. The thing here is that whenever such things come, we will not be able to do recursion in order to get the nodes in this order, the order in which we want, for the reasons that we discussed yesterday. Now talking about these levels, now we know that we have to define some indexing considering your root node as your origin, for example, then what I need to do, we will again do the same thing. We will take a queue. So this queue will take care which nodes are being added along with their horizontal distance from the origin, that is your root node. Okay, the very first node that I add into my queue, so I am going to traverse this tree in this level order in such a way that each time I am adding a node, I am adding its horizontal level as well. So this queue will be of type pair. This is something that you need to understand. This is the reason we create a pair class. Now other data structure that we will use is your hash map, which will finally contain indexes, right? It will have index, and corresponding to that index, what all. So index is the horizontal level basically. So based on those indexing, what all nodes I got will be there in your map. Okay, map will be of this. Now let's see the traversal. You will quickly understand. So I am going to start it in this way. We created a queue of type pair. Okay, then I added my root node. Root node is 1, and what is the horizontal distance? I will consider this vertical level to be 0 indexing. This will be your -1 indexing. This will be your -2 indexing. This will be 1 indexing. This will be 2, and this will be 3. This is your third index. Okay, but that's what I have shown here for the illustration purpose. How are you going to evaluate? Let's have a look. So you enter the root node and its horizontal level, that is 0. Now you will check if your queue is empty. No, queue is not empty. So you consider the one that is present in the front of the queue. You know, queue follows first in, first out. So now my task is that I add both left and right child of the node that is present in the front of my queue, right? And along with addition of those nodes, I will also add their horizontal distance from the current node that I am present. So from the current node, the left node will be at a horizontal distance of its distance, that is 0 minus 1, and the right side will be at the distance of 0 plus 1, right? This is very obvious thing. So based on this understanding, we are going to add and remove the nodes from your queue. So right now my current node is 1, and this is the only node that is present in my queue. So I'll take this, okay, I'll take this and remove from the queue and add what? And also in my map, so here I am taking the map. In my map, I will simultaneously be adding the indexing, which is the horizontal distance. So corresponding to 0. Why? Because based on this horizontal distancing, I will have a track of what all nodes I found on that horizontal distance, right? So corresponding to 0 index, right now I only got 1. So I have added 1 here. So map will be of type integer and an array list of integer. Why? Because I want all set of nodes that are present on that vertical level. Okay, move ahead. Let's move ahead. I remove this. I add its left child, which is 2, and its horizontal distance will be 0 minus 1. So 2 and minus 1 is what I'm going to add, and simultaneously I will add its right child, which is 3, and its horizontal distance will be 0 plus 1. So this is what I added into my queue. Right now my queue has only 2 nodes, and I've already added that map. The moment you are removing the node, the front node from your queue, that is when you are adding your indexing, corresponding index in the value in your map. Now which is the front node? 2 and minus 1 is its horizontal distance. So I'll check in my map. This is my current node I am considering. Check if minus 1 indexing is present. No, minus 1 is not present. So corresponding to minus 1, which node you found? 2. So you remove it from the queue. And what is the left child of 2? 4. So you add 4 into your queue, and what will be its horizontal distance? That will be the distance of this minus 1. So minus 1 minus 1, that is minus 2. And add its right child. So right child will be, right child of this 2 is 5. So you add 5 into your queue, and the horizontal distance will be its own distance, which was minus 1 plus 1. So that will become 0, right? Okay. Now next step was to add into map, which we have already done. Now see, consider the front of the queue. Right now my front is 3 and its horizontal distance is 1. I will ask my map, is there any index key with of 1? No, 1 is not there. So I add 1, and I add on basically corresponding to 1. There is a new array list that I am adding, which will have 3 as the element first in its array list. So these are array list actually. So the elements that I'll keep getting, I'll be adding it here, and you will see that this order of traversal will ensure that the nodes that are present on that level before, from starting from left, will come first in your array list. Okay, let's move ahead. Now this one has been removed and I have to add its left and right child. So the left child, 1 3, left child of 3 is 6, so add it to your queue and its horizontal distance, which is 6, and horizontal distance is its distance minus 1, that is 1 minus 1 0. Okay, then next child that you are going to add is its right child. So the right child of 3 is 7. This is the right child of 3. You add it, and what is the horizontal distance of 7? It will be its distance plus 1. So 7 and 2. 7 and horizontal distance is 2. That's what you are adding here. Okay, let's check now. Now what is the front of your queue? This part is done. Front of your queue is 4 and minus 2. We have to remove this node, and for that first I will check, is there any indexing minus 2? No. So I'll add this index minus 2, and corresponding to that a new array list has been added which has 4 in its first 0th index. Okay, basically. So okay, now add 4th left and right child. So where was 4? 4th left and right are null, so nothing will happen, means we will not add anything. We move ahead, and the front of queue is 5 and index is 0, horizontal distance is 0. So I'll check, is there any index 0 present in my map? Yes, a key with 0 is present. So in its array list, add this value which is your node data, which is 5. So you see that 0 is the vertical indexing which contains an array list of nodes that are present on that vertical line, and you see first I'll get 1, then I'll get 5, and you'll see that we will now get 6 also in the exact order we wanted. Okay, move ahead. There is no left and right child of 5, so we remove this simply and move ahead. Now we have 6 0. I have to add left and right of 6. Before that, I'll see if 0 index key is present in my map, which is, and corresponding to that there is an array list in which I will add 6. Now remove it from your stack, from your queue, and add its left and right child. Left is null, right is 8. So 8 will be added along with the indexing, which will be 0 plus 1. So this is what I've added here. Okay, fine. Move ahead. Now I have 7 and 2. So do I have a index 2 in my map as a key? No, there is no index with 2. So I add a 2 here. Don't bother, means if I'm writing 2 here doesn't mean it is in the same order, just for the representation. So 2 will have an array list which will contain 7, okay, as of now, and remove it from your queue and add its right child, because there is no left child of 7. So 9 will be added, a new node will be added, new pair will be added whose node is 9, and your horizontal distance will be 2 plus 1, that is 3. Okay, 7 and 2 has been removed. Now your front of queue is 8 1. So you check, is there any index 1? Yes, index 1 is present. So you add 8 in its array list. And next what? So corresponding to 8, do I have any left and right child? Clearly not. So you move ahead and see the last pair I have is 9 and 3. Do I have an indexing 3 in my map? I don't think so. So we add a new index 3 and a new array list with value 9. And you remove it from the queue. That is the end of iteration on queue, because there are no more nodes to add. Now you see that we have finally gotten a hash map which contains nodes based on their vertical indexes. Now what I want is, which is the leftmost index in the label. So the horizontal indexing is like this, and I have to print the values from left to right. So I will check -2 indexing. The node that it will have should be printed first. You iterate over its entire array list and print it. Then after -2 I will have -1. So the node that it contains is only 2. Then after -1 I should have 0. All the nodes one by one present in this array list will be printed. Iterate over its array list. So I will have 1 in the same order, 1 5 6. Now after 0 indexing I will go to 1 index and then print 3 8, and then last index, second last index is 2. Corresponding to it I have only 7. I'll print it, and then corresponding to 3 I only have 9, and this is exactly what we wanted, right? So if you have seen yesterday's lecture, that is printing the bottom view of the binary tree, we will the entire code you'll see is going to be similar. Just one extra change will be that this time your hash map will have will be of type integer and array list, right? Because I want all the nodes on that vertical level, contrary to bottom view, in which I only wanted the node that I was able to see from the bottom views. That would be only one node, right? So we were every time replacing it. So this is the only difference that we have from the previous and today's lecture. And I hope you will understand that how we are keeping a track of the leftmost index by taking an extra variable min and by taking an extra variable max to keep the track of extremes on the vertical indexing, so that I can directly traverse from min till max, and in the same order I can print the values. The other way around is you can take a tree map, so it will ensure that all the indexing that you are adding will be in sorted order. Okay, so this is the other thing that you can do. Since we have done using two variables in the previous code, I'll almost take the same thing and show you. Fine. So that is all about this problem. In case you have any doubt, okay, I can see some comments here. Hello guys. Yeah, there Shankar. If you have coded using tree map, it's completely okay. As I discussed just now, the alternative way, in fact a better one, would be that you use tree map. It will have the indexing already in the sorted order. We will not have to use extra variables to track them. But since yesterday I discussed that, we'll go ahead with it. Okay. So if you guys have any doubts, you can ask me. If not, I'll show you the code here. Completely, I have myself copied yesterday I coded it in the class. I have taken the same code from your previous lecture. The extra additions I have done here is that you are adding a new array list if the key that you are adding is for the first time. So for that you are keeping a check. If map.contains this, you are basically adding, sorry, if map does not contain it, you are adding a new array list, and then you are adding your current.end.data. So for that, you'll just have to do a little recap from the previous lecture, because I've already explained it in detail. So yeah, you are right. Actually, time complexity will not increase much. Okay, so that is all about this question. There's nothing left to explain here in this, because the similar explanation was there in the previous lecture, so you guys can go through it, and that's all. The main thing was traversal, which is exactly similar from previous and today's lecture, and I've explained both of them in detail. So I hope now the things are clear. If you have doubts, let me know in the chat. Otherwise, we will wrap it up. Okay. Thank you guys. Thank you for your participation. Fine then. See you all in the next lecture. Bye bye and take care.